One leaf, one clue, one decision. That's all it takes. Most people see weeds. Prospectors see possibilities. And sometimes, the difference between those two perspectives is worth millions. A lonely hillside, dry soil, endless silence. Nothing unusual, nothing valuable. At least, that's what most people think. But some of the world's most remarkable discoveries began exactly like this. Not with a gold nugget, not with a metal detector, not with expensive equipment, with a question, a simple question. Why is that growing there? Welcome back to ProGems, where geology becomes treasure and nature hides clues that most people never see. Tonight, we're exploring one of the strangest secrets in mineral exploration, a secret rooted in living things. Because certain plants don't merely grow from the earth, they respond to it. The earth leaves fingerprints, invisible fingerprints, buried beneath layers of rock. Ancient geological signatures formed millions of years ago. Most people never notice them, but some species do, quietly, faithfully, year after year. And when experienced prospectors notice those responses, they pay attention. Because every unusual pattern raises a question. Why here? Why nowhere else? And what lies beneath? Sometimes, the answer changes everything. Pause for a moment. Imagine standing in a remote wilderness. No roads, no buildings, no signs of civilization, just wind, stone, and vegetation. Nothing appears valuable. Yet hidden beneath your feet could be a fortune. Gold, copper, nickel, rare minerals, all invisible, all waiting. The challenge has always been the same. How do you find something you cannot see? For generations, prospectors searched rivers, studied rocks, followed mineral veins. But eventually, scientists discovered something astonishing. Nature was already doing part of the work. Certain plants absorb elements from the soil, tiny amounts, microscopic amounts, but enough to reveal information, enough to expose hidden geological conditions, enough to leave clues, and those clues changed everything. Because suddenly, vegetation became evidence, not proof, but evidence. And in treasure hunting, evidence matters a lot. One prospector sees a patch of green, another sees geological information, one keeps walking, the other investigates. Years later, only one remembers that day, because observation changes outcomes. And nowhere is that more true than mineral exploration. Now let's travel to Australia, a vast landscape, ancient rocks, some of the richest mineral regions on Earth. For decades, geologists studied strange relationships between vegetation and hidden deposits. Then something extraordinary happened. Researchers began examining eucalyptus trees growing above buried gold systems. At first glance, the trees looked ordinary. Nothing remarkable, nothing suspicious. Just trees, but science revealed a different story. Deep underground, far below the surface, tiny particles of gold existed within ancient deposits. The roots of eucalyptus trees stretched downward in search of water. Some roots reached astonishing depths. As water moved upward through the tree, microscopic traces of gold traveled with it. Not enough to make the tree valuable, not enough to harvest, but enough to detect, enough to measure, enough to tell a story. Think about that. An ordinary tree, standing quietly beneath the Australian sun, carrying evidence of hidden gold, evidence invisible to every passing traveler, yet visible to those who knew where to look. Suddenly, a tree became a clue, a living indicator, a biological messenger from deep underground. And that discovery captured imaginations across the geological world. Because if a tree could reveal hidden gold, what else might nature be revealing? That question opened an entirely new door. And behind that door, even stranger discoveries waited. But before we go further, consider something important. Most fortunes are not found because someone got lucky. Most fortunes are found because someone noticed something others ignored. That is the real secret, not luck, Observation. A prospector walks through a landscape. Everyone else sees scenery. The prospector sees patterns, subtle differences, tiny anomalies, details most people dismiss. And sometimes, those details lead directly to wealth, because nature rarely announces treasure. It whispers, very quietly. Now the mystery grows deeper, because gold isn't the only mineral connected to unusual vegetation. Far from it. Let's talk about another remarkable indicator species, Alyssum, an unassuming plant, small, easy to overlook, nothing glamorous, nothing dramatic. Yet beneath its modest appearance hides an extraordinary ability. Certain species of Alyssum thrive in soils rich in nickel, soils toxic to many other plants, places where ordinary vegetation struggles, yet Alyssum survives, even flourishes. Scientists call some of these species hyperaccumulators, living organisms capable of absorbing astonishing amounts of nickel. The numbers are remarkable, the implications even more so, because where these plants appear, geologists often take notice, not because the plant is valuable, because of what the plant suggests, because hidden beneath the surface may lie something far more valuable. A mineral system, a deposit, a discovery waiting to happen. And once again, nature provides another clue, another breadcrumb, another piece of a puzzle millions of years in the making. But the story doesn't stop there, because the next indicator species reveals something even stranger, something almost unbelievable. Meet Astragalus, a plant linked to selenium-rich environments. Certain varieties became famous among prospectors and geologists for a surprising reason. They could tolerate concentrations of selenium that would harm many other species. In some regions, their presence became a signal, a warning, a clue, evidence that unusual chemistry existed below. Imagine hiking across an ordinary landscape, then suddenly encountering vegetation thriving where logic suggests it shouldn't. Would you ignore it, or would you ask why? That single question has led to countless discoveries, because geology is often a detective story, and every clue matters. The rocks matter, the soil matters, the water matters, and yes, the vegetation matters too. Now step back and look at the bigger picture. 3 different indicator species, 3 different geological clues, 3 different stories, yet they all point toward the same truth. Nature notices what humans overlook. Long before satellites, long before drilling rigs, long before laboratories, the landscape was already responding to hidden geology, already displaying evidence, already revealing patterns, waiting for someone to pay attention. And perhaps that's the most fascinating part of all, because these clues surround us every day, silent, patient, easy to miss, yet potentially life-changing. Imagine discovering that a fortune existed beneath your feet, and the only visible warning sign was a patch of unusual vegetation, a cluster of leaves, a tree, a flower. Would you have noticed? Most people wouldn't. Prospectors might, and that difference can change everything. But what you've heard so far is only the beginning, because one indicator plant became so mysterious, so unexpected, that researchers initially struggled to explain what they were seeing. Its relationship with buried minerals challenged assumptions, raised new questions, and hinted at something even more extraordinary. A clue connected not merely to hidden deposits, but to one of the rarest geological mysteries on Earth. A mystery that still fascinates prospectors today. And once you hear that story, you'll never look at a landscape the same way again, because the next plant doesn't simply reveal buried wealth, it reveals a geological secret almost nobody knows exists. And that's where our journey continues. In the world of geology, there are places where the Earth is chemically unusual, not just slightly different, but extreme. So extreme that most plants cannot survive there at all. These are called serpentine soils, formed from deep oceanic rocks pushed up onto land over millions of years. They are rich in heavy metals like nickel, chromium, and cobalt, but poor in nutrients that most life depends on. To most plants, these soils are toxic, dead zones. But nature always has exceptions, and those exceptions are where things get interesting, Because in these harsh environments, a few rare plants don't just survive, they adapt, they specialize. They become living signals of what's beneath the surface. Picture a barren-looking hillside, sparse vegetation, strange, stunted growth, nothing that looks valuable. Most people walk past it without a second thought, but a trained observer pauses, because in geology, nothing grows here is sometimes the loudest clue of all. Why? Because soil that refuses most life is often chemically loaded with minerals that matter, and nature is already reacting to it, quietly, consistently, predictably. Now here's where it gets even more powerful. Some plants don't just tolerate these conditions, they absorb metals directly into their tissues, not by accident, not in tiny traces like normal vegetation, but in measurable, significant amounts. This is the world of hyperaccumulation, a biological anomaly that turns plants into natural detectors. Imagine a plant pulling nickel from deep underground deposits and storing it in its leaves, not enough to notice by sight, but enough for science to measure, enough to map underground chemistry, enough to guide exploration. And prospectors learned something important from this. They stopped only looking at rocks. They started looking at biology, because biology was quietly doing what drilling hadn't yet done, revealing what was hidden. In some regions of the world, especially parts of Southeast Asia and Africa, researchers discovered entire plant communities that behave like living metal maps. Different species dominate depending on what lies beneath. Nickel-rich zones, copper-rich zones, even cobalt anomalies, each one influencing which plants can survive there. Not randomly, but systematically, like nature drawing invisible boundaries across the land. And then came another breakthrough. Something even more surprising. Certain plants don't just reflect mineral presence, they can concentrate elements to levels far higher than the surrounding soil, meaning a single leaf can contain a chemical signature of what lies deep underground. This turned vegetation into something extraordinary. Not just life, but a detection system, a biological survey tool. But here's what most people miss. This isn't about plants finding gold, like a fantasy story. It's about patterns, subtle, repeatable patterns, where geology influences chemistry, chemistry influences soil, soil influences vegetation, and vegetation becomes readable evidence. Now imagine standing on a remote slope again. Nothing obvious, no machinery, no noise, just wind and silence. But beneath that silence, a system is speaking. The rocks are speaking through chemistry, the chemistry is speaking through soil, and the soil is speaking through plants. Most people never learn to hear that language, but prospectors train themselves to. And this is where the story takes a sharper turn. Because once geologists understood indicator plants, they began to test something bold. Could vegetation help predict not just mineral presence, but the size and richness of underground systems? Early studies suggested something remarkable. Stronger plant responses often aligned with stronger mineralization below. In other words, the louder the biological signal, the richer the geological source. But nature doesn't make it simple, because not every anomaly means wealth, and not every strange plant cluster means a deposit. False signals exist. Climate affects growth. Water changes chemistry. Time reshapes ecosystems. So interpretation becomes everything. Not observation alone, but understanding what you're seeing. And that's the real divide between a passerby and a prospector. One sees irregular vegetation and dismisses it. The other asks, what changed here? What's different underground? Why here and not there? Because in geology, the most dangerous mistake is assuming normal means nothing. Some of the richest mineral discoveries in history were hidden beneath landscapes that looked completely ordinary. Flat ground, dry vegetation, unremarkable soil, until someone looked closer. And that brings us to the deeper truth behind everything you've heard. Plants are not searching for gold. They are responding to chemistry, but chemistry is shaped by geology, and geology is what holds the story of the Earth's hidden wealth. So in a way, plants are accidental messengers, silent witnesses, living indicators of ancient processes buried far below our feet. Now imagine what this means for exploration today. Satellites scan from above, sensors read from below. But between them sits something older than technology, something alive. Vegetation that carries signals no machine designed, no human engineered. Signals written by nature itself. And yet, even with all this knowledge, most people still walk past it, still see only green, still see only weeds, still miss the patterns entirely. Because the difference has never been about access. It has always been about attention. And somewhere right now, there may be a hillside that looks completely unremarkable, a patch of unusual growth, a cluster of plants thriving where they shouldn't, a silent hint, a biological clue, waiting for the one person who understands what it means. And that is where the real story begins to change. Because once you learn to see these signals, you don't just look at land anymore. You interpret it, you question it, you read it, and every landscape becomes something else entirely. A possibility, a pattern, a potential discovery. But even this is not the final secret, because there is one last layer, a final connection between vegetation, geology, and hidden mineral systems that scientists are still trying to fully understand. A phenomenon so unusual that it blurred the line between biology and geology even further. And it raises one final question. If plants can reveal what lies beneath the earth, what else might the earth be revealing through life itself?